To another video about SolidCP Entity Framework port, about the data layer, the new data layer of SolidCP. And so we're gonna look at it. The SolidCP 151 is not using EntityFramework. And so in order to use EntityFramework in the new SolidCP version, I created this project here, SolidCP Enterprise Server Data. In this project, all the database layer code is resided. And then the old database layer, there's one main class in SolidCP Enterprise Server Code that is accessing the database, and this is data provider here in SolidCP Enterprise Server Code in the folder data. This data provider class, it's a huge class with all the database access methods. And we can look at one method, for example, add audit log record. All those new methods, they now distinguish between EntityFramework access and the old SQL access. And so they do this by, if you use EntityFramework, you can configure this either to use EntityFramework in the database layer or to use SQL. And if it uses EntityFramework, it's calling EntityFramework code on data provider. Data provider inherits from DB context. As you can see here, data provider inherits from DB context, so you can call those methods here. Save changes, for example, is a method from the DB context, and you can call those methods directly in the database code. So this adds an audit log record. It first creates an entity class audit log, and then it adds it to the audit logs DB set, and then it calls save changes of the DB context. An audit log is a DB set property of the DB context. And here is the old code that's identical to the old code in SolidCP 151. And this just calls the store procedure add audit log record. And that's, you can see all the other methods, it's using the same principle. If you use EntityFramework, and then there's EntityFramework code to access the database. And then there's the old code accessing SQL store procedure. Okay, now in order to debug this EntityFramework code, that's a little bit difficult. But you need to be able to compare the store procedure SQL to the EntityFramework code. And you do this, in order to do this, all the store procedures are stored in a new location, not just in install DB SQL, as it was in the old SolidCP. If we look here at this data project, we have a folder migrations, and here we have MySQL, PostgreSQL, SQLite, and SQL Server. Actually, PostgreSQL is not fully supported at the moment, but nevertheless there are migrations for it. And here in this folder migrations, there are the EntityFramework core migrations, and we have two folders here. 151 that is a migration that creates a database for SolidCP 151. And if we upgrade from 151, it just enters this 151 migration into the EntityFramework table. So that EntityFramework is assuming that the database already exists. And so we have here the migration code, then this is the context menu model snapshot from EntityFramework, and this is just a backup of the snapshot. It's, you see the build action is set to none, so it's just a backup of the snapshot. So in order, if we need to restore a migration from scratch here, if we add here a new migrations and we want to combine all those migrations into one migration for version 2.0, then we can restore the snapshot here. We can say here compile, and the latest snapshot we can just say none, and then if we add a migration, it will add a migration from the 151 snapshot. So that's how it works. And if you create a new migration, it will create the snapshot here in the root folder, in the SQL Server root folder, and there will be a snapshot here, and then you need to back up this snapshot to the version folder you are creating a migration for. Need to turn this back on. Okay. And the store procedures, as we talked about here, they are stored here in V2. Might be we also introduce a store procedures folder for version 151, but we have here the store procedures for version 2.0, and here are all the SQL files for every store procedure, and also for user-defined functions, and for a view, and also for a trigger function. There's one trigger function. I think the trigger function is up here. This is a trigger function. And if you look at the code here, like user-defined function, it's just the SQL code to create that function. And that's how we can compare the SQL code to the EntityFramework code. So we can look at this here, get audit log records page, and then we look in the stored procedures, get audit log records paged, and we have it here, get audit log records page, and then you put it in the right pane, and then you can compare the EntityFramework code to the store procedure, and can debug the EntityFramework code. Okay. Okay. So yes. Okay, so we have seen the store procedures, and those store procedures, they only exist for SQL Server. SQLite doesn't have store procedures, and MySQL neither does have store procedures. MySQL and SQLite, they only use EntityFramework, no store procedures. Okay. Then we have here in those folders an install, and then the database flavor SQL file. And this is a idempotent database script to install the database. And you can apply this script to the SolidCP 151, and it will upgrade the database to the newest migration. And only SQLite, you cannot use this script to upgrade the database. In SQLite, you cannot upgrade the script. You only can initialize the database with this script, but you cannot upgrade it because SQLite doesn't support conditions like if. It doesn't support if, so it's not possible to create an SQL script for SQLite to upgrade the database. If you want to upgrade an SQLite database, you need to use methods from database utils here in SQL extensions. There's a class database utils, and this class database utils, it contains a lot of database functionality used by the installer, like creating a database and changing the server admin password and deleting a database. This is methods meant for the installer. And here, if you want to upgrade the database, you have to call this method update database. Let's have a look where that method is. Here, this method you have to call. If you want to update the database with SQLite, you cannot just run the script, you have to call this method here. And what this method does, if the database type is not SQLite, it runs the script, the install SQL script. This script here we've seen before. And if it's SQLite, it just calls context migrate to upgrade the database. Okay. All right. So the structure of this SolidCP Enterprise Server Data project, we have here in the folder entities the entity classes of all the tables, of all the database tables. We have here configuration classes that configure the database tables with Fluent API, the EntityFramework core tables. And we have here all the entity classes, like for example provider. This is the entity class. And we have, as you can see here, we have special code that's only runs on .NET Core, and code that only runs on .NET Framework. And we can distinguish by those symbols that are defined in the project. And this attribute index is only supported in .NET Core. So we only call this index function in .NET Core, but it doesn't matter if we don't have this index attribute in .NET Framework, because the index attribute, it's only used on creation of the database, not when we are running the database. We don't need this information, and we create the database always using EntityFramework core and not EntityFramework. Yes. And we see here the entity class, it has attributes for all the properties. And then we have here the configuration class of provider's configuration. That's here. And you can see here we have one version for .NET Core and one for .NET Framework. .NET Framework is using System Data Entity, it's using EntityFramework 6. And .NET Core is using Microsoft EntityFramework Core, it's using EntityFramework Core. At the moment it's using EntityFramework Core 9. And we have November now, it's 4 days until they release .NET 10. So we will be using EntityFramework Core 10 here, but we have to wait for using EntityFramework Core 10 until the MySQL provider for EntityFramework Core 10 is ready. And then we can use EntityFramework Core 10. Okay, we see here the configuration class. it's inheriting from a custom class entity type configuration provider, and this class here has some base types that we can use. Let's look at this class. It inherits from entity type configuration entity, and for .NET Core, and for .NET Framework it inherits from system data entity model configuration entity type configuration, and for .NET Standard it's just a class that inherits from nothing. So and then we have here the basic methods, and it has annotation. It uses builder has annotation, but some of those methods are only available in .NET Core, as we see here, and some yes, and we have some are available also in .NET Framework, like ASCII is available in .NET Framework and .NET Core, but not all of those methods. So we need to distinguish here between .NET Core and .NET Framework. And we provide here a name for the primary key here, and then we specify that that the primary key is now an identity key, but is specified by code, not by database auto value. And then here is some relations on the providers. But actually I'm wondering why this has one is only specified here and not also for .NET Framework. I think this should be specified too. Yes, has required, of course, is the same as has one. This is also this same relation is defined here for .NET Framework, T group and providers, with many providers. And then there's seed data. We have some seed data for the providers table, and this is also in provider configuration. And this is the seed data we had before in the SQL code. And it uses the function has data. And if you look at this function has data, it takes a function of an enumerable, and this is so that this code here, it's only called when actually the seed data is needed, and in order to speed up the creation of the DB context. So this is a function that creates all this data, in order that we can call this function only if you really need to initialize the seed data and speed up things a little bit. Okay, and this creates just an array of providers, and here we can see all the data of the provider objects. You don't have to code this seed data yourself. If you're using the old 151 database, we can scaffold the database with this script here, scaffold path, It does scaffold the database, and the database scaffolding also includes the seed data. So this is the command for scaffold of .NET EF DB context scaffold, and then the connection string. And I don't know, this is just parameters to scaffold, data annotations, output tier, entity sources, context. That's the command to scaffold the database. And what scaffolding does, it creates all the configuration classes here, but it puts them in sources. So those classes here are the scaffolded classes from 151 version of the database. And also, if someone still works with the old branch of SolidCP, with the master branch, and he does introduce complicated changes in update DB SQL, that was the old method of updating the database, just modifying the update DB SQL script. And if someone introduces changes there and you don't know how to apply those changes to the EntityFramework code, because now we need to adapt the EntityFramework code if you want to change the database, and we don't use update SQL anymore. So if someone changes, you can always do a scaffold of the new database. You can apply update DB SQL to a test database, to initial database, and then you can scaffold the resulting database, and you get all the entity configuration classes here in the folder sources, and the entity classes, the scaffolded entity classes here also in the folder sources. Those are the scaffolded entity classes. And yes, so you can, yeah, and you see the changes made to those classes here through this version control. So you see which classes have been changed by the scaffolding, and then you can apply those changes to the real classes in the entities or configurations, configuration folders. And there's also another class scaffolded, and that is this class here. This is also the scaffolder class, DB context space source. If you look at it, it has a DB context that is inheriting from the EntityFramework DB context, and it defines all the DB set properties, and then it calls the configuration classes here, apply configuration model, and then the configuration classes it applies for the Fluent API configuration of the entity classes. And then it has also for each DB set it initializes the DB set and adds a property DB set. This is a different class. It's the class DB context. That is this class here. This is a parser class, and it declares the DB sets on this parser class. And in order to also support .NET Standard, we need to have a little bit special. This DB set, we need to define it a little bit specially, because in .NET Standard there is no DB set. So we declare a DB set for .NET Standard in extensions. This is the DB set for .NET Standard with .NET Standard, and it just returns the function set entity as an equariable. So it declares it DB set is an equariable, and it calls the base context that is either .NET Core or .NET Framework, and it calls the set function to return a DB set. Yes. And so we can also support .NET Standard. Yes, so this is the DB sets on the DB context class, and the main DB context class, this class here, it's actually not an EntityFramework DB context. It's just a stub that calls on the EntityFramework DB context. The EntityFramework DB context is DB context space. That's inheriting from the EntityFramework DB context here, from System Data EntityFramework, or if we are on .NET 8, it inherits from Microsoft EntityFramework Core, as we see here. And this is the DB context class, DB context space, and the main DB context class is just a native disposable, and it has methods that it has a property base context. Where's that property? Let's have a look. Base context here. That's going to the proper DB context, and this is an eigeneric DB context. And if we look at the implementation, it has a method save changes. It has a method to retrieve the DB set for an entity, and it has a log, and it has a database facade, but only for .NET Framework or .NET Core app, not for .NET Standard. Yes, and so on creation of this DB context, it creates a base context and creates a new EntityFramework DB context for its base context. We also have a folder legacy scripts. The folder legacy scripts, there is the old install DB SQL from SolidCP 151. We have the old update DB SQL, and there's a bunch of other scripts like drop DB SQL. This will drop a database, so you can reinstall it. And then there's set server admin password. This SQL just updates the server admin password to 123456 in order to set the admin password on a fresh installation. Yes, that's the legacy scripts. Then in order to create a migration, we have those scripts here, migration remove and migration add. And usually when I create a migration, I don't call the scripts directly, but it's actually quite a huge script, and it takes quite some time to complete. So when I create a migration, usually I only, when developing, I only use SQL Server. And so I only develop for SQL Server, and later on when my features are stable and my database features are stable, I also create the migrations for MySQL and SQLite and PostgreSQL. So this script, it asks for a name for the new migration, and then it compiles the EntityFramework data project, and then it adds a migration according to this name here that you have entered. We see here the variable of the name of the migration, and then it does this for every database flavor, for SQLite, SQL Server, MySQL, and PostgreSQL. And after it has created all the scripts, all the migrations, I mean, it's creating the database scripts for the migrations for SQLite, SQL Server, MySQL, and PostgreSQL. And then there's another feature that also would create a bundle exe, install SQLite bundle exe, but we did comment this out, as we don't use bundle exes, we don't use migration bundles, because I'm not sure that if they are the bundles are OS dependent and don't work on every operating system. They only work on Windows, and also maybe not on Windows for ARM, and so there's issues with the bundles. And so we prefer, if we migrate the database by code, we do this by using database here, this database utils for migrating the database, if we use code and not install the scripts. So usually when I create a migration for developing, I'm using only this first line here, and I go to the developer prompt, and then I go to the data project, and then I just copy and paste this part of the migrations add script. First I ask for a name of migration, and let's call it version 1.01. And then we add a migration for SQL Server. We copy this line here and paste it into the command prompt, and then it will create a migration. And now we have this migration inside the SQL Server folder, and we would need to, if we are working on version 2.02, we need to copy this migration into this folder here, and also this one here. And we would create a backup of this. We would rename this model snapshot so it doesn't overwrite it when we create a new migration. So we have a backup of it. Then we disable this old snapshot. We put build action to none of the old snapshot. And now we have here the actual snapshot of the database here and all our migrations. And if we want to combine those migrations into one, if we have done our development and we feel secure that we don't need all those migrations here anymore, and we just want to have one migration, then we just delete all those migrations here. And as we can see here, this should be empty, this migration, because we didn't change the database. So we just delete all the migrations and all the model snapshots. And we also need to not compile the stored procedures. We don't delete the stored procedures. This initializes the stored procedures, but we put compile to none because it's a partial class part of the migration. But we need this store procedures. We don't delete it, and then we can create a new migration for only version 2.1, and then we need to re-enable this model snapshot for version 1.5.1 here. We put this to compile in order that the migrations use this snapshot here, and if we create a new migration, it will create a migration from this snapshot on. From this snapshot from 1.5.1 on, it will create the migration. So let's build enterprise server data. And this succeeded. So let's let's name the migration in a new migration. We use this version 2.2, and then we add a migration for enterprise server, for SQL server. And now we move this migration here to this folder. And we name it version 2.0. And then we re-add the store procedures. And the store procedures, they are applied here in the migration, but we apply them at the end of the migration. This is the end of the up method of the migration, so we call here store procedures up with the migration builder. And this is just the method of store procedures. We have here store procedures up and store procedures down that just drop all the store procedures. And the store procedures up, it calls an SQL script with a path to the embedded resources. You have here the store procedures, and those are all embedded resources, those store procedures. So we call here an SQL script with the path SQL server, that's this folder here, version 2.0, that's this folder here, and then store procedures, that is this folder here. And between the folders there's always a dot for embedded resources. There's not a slash, there's a dot. And then we have any text here, and at the end SQL. So this is a regular expression that is applied to all the embedded resources, and then this method SQL script, it will apply all those SQL to the migration. So this applies all the store procedures. We can have a look at this method here, SQL script. It's calling a method save SQL, and this method save SQL is it's applying this SQL here from the variable query, and if it's necessary, it's embedding this SQL into a execute store procedure call. So in order, it can also handle SQL that would otherwise not be valid in a main context. We can look at this save SQL here further. If there's a create alter, it's a create alter or function, then if it has a special command, we just call this execute execute SQL, and then we put the actual SQL into this would be the actual SQL, the command variable, and we replace just string literals by double literals, and then it executes this SQL safely. So we can call this SQL safely in the migration. Yes. Okay. Yes. And we do recover the old migration, because if we introduce here Ja, ist gut if we introduce here a new migration. This will give us trouble, so we delete this one here. Okay. Yes. So, and I'm not so sure yet how you want to do this during development. If you just always create a new migration in for SQL, but then if you publish this commit of this the development, others might change their database to include this migration, and also it's a problem if you merge different forks that were both working on migrations on the database. This might introduce conflicts, and so yes, it's always best for every migration to make a backup of the model snapshot. So you can always restore this model snapshot and introduce a new migration. Okay. Yes, the migrations here, they actually use a custom DB context. Here context, it uses SQL Server DB context, and those contexts, they're only used for migrations, and they're here in this file generic DB context. And so there's a class generic DB context, and using a DB provider, one for MySQL, and one DB context for SQL Server, one for PostgreSQL, and one for SQLite. And there's also an Oracle DB context, and MariaDB DB context, and here's the class generic DB context. And those generic DB contexts, they're only used for migrations. And we also have some extensions to EntityFramework core that are I don't know, queryable extensions. Yes, we are using this set EntityFramework Plus, and this is we are using the free version of set EntityFramework Plus and not the commercial version. And so we are defining an execute delete for .NET Framework that's using this delete function from set EntityFramework Plus. So we can have the in .NET Framework Core. In the .NET Core, there is a method execute delete in EntityFramework Core, and so we have this function also for .NET Framework, and there's also a function execute update. There is already an execute update method in EntityFramework Core, but we use the syntax of this update method of set EntityFramework Plus. So let's have a look at how this looks. Here we update the quota table. We just have a filter on the quota table and then execute update quota, and then we create a new entity quota, and we change this property of quota to the new value. And this is actually equivalent. We still have some code that doesn't use this execute update method. This would be the old flavor code we distinguish for .NET Framework, and we use normal entity framework for each to change the property and after the save changes. And for entity framework core, we use the entity framework core execute update method with set, and then the set property method on the set to call update on the database. But this function here is actually easier to code with, so we could also just use this method here instead of this code here of entity framework code. Yes, and those are some extensions to the DB set. And then yes, I think dynamic functions. Yes, we have a method column like that you can specify a column name and a like expression. So it calls a like on that column with that like expression. And we can look here on an example where we use this. And this, if we have in this method here get users paged, and we have a filter value that we want to call the SQL like function on this column here. The name of the column is in filter column, and so we can use this dynamic functions column like on the iQueryable users. And if we use the ordinary like, we can look here at the we are using the ordinary like. We have to distinguish between .NET Framework and .NET Core. For .NET Framework, if we want to use SQL like, we would use DB functions like, and for Entity Framework we use EF functions like. So for the like function, we have to distinguish here between .NET Core and .NET Framework. Yes. Yes, we also have one important extension, Entity Data Reader. Here, Entity Data Reader, it's an iData data reader that is enumerating on a set of entity classes, and this is here the set of entity classes. And we use this class here in Data Provider. We can call this method Entity Data Writer, and then we specify an entity data set. We use this like so. In the Entity Framework code, we just enumerate on a table system settings, on a DB set system settings, and then we just return an entity data reader of those settings in eData Reader. So if we look at this method, we can also specify a count, and then it's first returning an a data reader just for the count, and then a data reader for the set. We can see this here. We have a value count that counts the VLANs, and then it returns count and the VLANs. And this method here, if we look at the store procedure, get private network, if you have a look at the store procedure here, It that would be this store procedure here. It actually returns two data sets. It first returns the count select, and then it returns this select here. And that's what we do here in the data provider. If we call the count, and then we return an entity data reader for count and also for VLANs, we actually return an entity data reader that will return two data sets, one for the count and one for the actual data set. And then we also have a method entity data set. We also have this method here that doesn't return a reader but a data set. And if we go to the definition of this, we also have one that takes a count, so it returns a data set with two tables, with one count and with one of the set. And it just returns an entity data table. And if we go to this entity data table, it returns a new entity data table. And if we go to the definition, we have this here also in extensions, an entity data table that is taking an entity set and it's filling a data table with all the data of the entity set. Yes. Yes, I think that's it. Yes, I think that's it. And we have this method object utils. It's actually, it used to reside in Entity server code here, the object utils. The object utils, it just fills an enumerable with a data set. For example, let's have a look at create list from data set. It calls fill collection from data set, and this would be a list and a data set, and then it fills this list from a data set, from data table, and then the list, if the data table is an entity data table, an entity data set, it calls fill collection from entity set, or if it's just an ordinary data table, it fills it from a data view. So it has some optimization if the data set is an entity data set. We can look here at this entity data set, fill collection from entity data set. And it just copies it gets all the properties of the two types, and then it copies over every property from the data set to the list. It just copies all the property. Yes. So I think that's it. What we didn't have a look at yet. These code templates. Here are the templates for scaffolding in the folder code templates. This T4 templates are used for database scaffolding, and this part of the code is used for scaffolding. Here we implement the scaffolding, and we have also to implement scaffolding of the seed data. It also scaffolds the seed data, and this is implemented here in this code. Yes. Yeah, there's also a backup folder in the migrations. This folder is nothing special. There's just backups. And actually, if you want to, you can delete this folder backup. It's not used anymore. It's just backups. Yes, and yes, I think that's it about EntityFramework. For testing, if you go to the portal, I have to look where I have the portal. Okay. If we go to the SolidCP portal, we can actually tell SolidCP to, in order to debug the database code, we can tell SolidCP either use SQL, store procedures, or use EntityFramework if you're running the database on SQL Server. If you're running on MySQL or SQLite, we always use EntityFramework. But we can configure this in order to test the EntityFramework code. We can also use EntityFramework for SQL Server. And you can apply this setting here in the system settings. But we have to wait for the portal to show up. Yes. It always takes some time when you first start the portal, because it has to compile all the control pages, all the ASCX pages, controls. Yes. So luckily I have a fast laptop. I'm very lucky to have a fast laptop, so it would even take longer on an old laptop. I used to have an old laptop, but it broke, so I had to buy a new one. Come on. Okay, now it's coming. So we can configure this here in the system settings. In the debug settings, we can say use EntityFramework for database access. We can say yes, and then save settings, and then it will use EntityFramework to access the database. And we will see this here, as it's a debug setting. We will have this checkbox here in the bottom of the page, so we can disable it again, and we can here just call this version without the EntityFramework or with the EntityFramework in order to debug EntityFramework code. Okay, thanks for watching. That's it. Have a nice day.